Hello and welcome to this section. So in this video we'll be learning how to add and subtract vectors and multiply them by a scalar. Okay, so in this very first example, uh, in the diagram we've got vectors a, b and c, and we've been asked to calculate what's the resultant vector abc, a plus b plus c. So first of all, from the diagram you can read what the units are. Components of A are 6 units to the right and 3 units up. So let's write it there. What's the components of B? It's 3 minus 2, and component of C is 0 minus 5. So when you want to figure out the resultant vector, means adding the components wise. Component wise means that those in x direction add together and those in y directions add together. 6 and 3 add up to 9. 3 minus 2 minus 5 adds up to minus 4. Alright, so it doesn't matter in which order. If we put the ends together, if we say go use A and then go use B and then use C, you end up with these units. So really we started here. Resultant vector is saying that in which the we find that we traveled on this, well, find this red line here, this final red line I'm double drawing here is the resultant vector, and it's pointing 9 units to the right. Actually, if I didn't draw my drawing carefully, I should have taken this down 1 unit further, but you get the point. Alright, so that's the resultant vector. Of course, with this example 2 here, uh, so is saying the triangle ABC has vector, like when you see arrow on top of two uh, letters, it means that it starts at point A and ends at point B. This little vector we're gonna call A. Where is A to B? So A to B is this line here. So this line in little a is like pointing downwards because it starts at A and ends at B. That's what the meaning of the arrow means. And this A to C is pointing from A to C. All right, so that's what it means. It does have a direction. This is B, and it's saying that P is a midpoint of AB. Okay, so this is halfway between A and B. That's what it means. The Q divides AC in a ratio of 3 to 2, so we put it like that. And write down in terms of A and B, what is B to C. So if I have to go from point B to C, the vectors are like highways. That like you want to travel from one point of city to another point of the city. You have to take the highways, or you can't just go through people's houses, right? So I know this B to C is connected with the line, but we only have these red vectors to work with. So pretend that that B to C line is not there. We have to use the red lines or the vectors because we were told to use in terms of A and B. Now there's no third vector C to use. So you have to go back on vector A. So that means putting a minus sign in front of A because we're traveling in the opposite direction from B to A and then from A to C. So write it for yourself. We have to go from B to A, all right, and then from A to C. Therefore, we go minus A plus B. You can rewrite this line as somewhat neater if you put B first and then minus A. You see this quite a lot. It might not make sense. How can I go use B before I have used minus A? Yes, this is just a rewriting algebra. Alright, so don't think that it has to be logical. Yes, I know you're standing at point B and you cannot use A to C already, but we will pretend that actually we can use it. We go in this direction. Vectors, think of it as something you can pick up and put it where you want it, somewhere. So when you use uh, B first, you're going in this direction, and then a negative of A will take you up to from this point up there. All right, so that's one way of thinking about it. So then from A to P. How can I go from point A to P? All you have to do is take half of A because it says, yeah, P is halfway, isn't it? So this is just half. You write half and then little a, and that's it. Now A to Q. Q was 3/5 of the. If you add the ratios together, you just need to think of it as, this means as a fraction is 3/5, isn't it? So 3/5 of B. You write 3/5 B. All right, you're going from A to Q, and finally P to Q means from midpoint here to 3/5 down there. So from P to Q, you have to travel. If you not sure what to do, just write down the corner-wise direction you're gonna go. You're gonna have to go cor- from the corner P, point P to point A, and then from A to Q. You kind of have these components written already. You have the reverse of A. You have to reverse this vector A to P. So we put a minus half A there, and ATQ we already solved it there in part C, so that's just 3/5 of B. Now it might be neater to write this as 3/5 B first minus half A. Okay, you in vectors they usually write the positive component first and then the negative component. So don't be surprised. Alright, so there's a couple of more examples to look at. So here I was just testing my students to see if this vector is A and it has those components, what are the components of 3A? Alright, so what do you think those question marks are going to be? Think about it. Alright, so you have 1.5 I, that means that's traveling in x direction. You times it by 3, you get 4.5. And when you have minus 1, you times that by 3, you get minus 3. Alright, so those are the components there. So here is just saying some stuff I've already said. Two vectors are parallel if their components are multiples or fractions of one another. Alright, so these 3A and A are parallel, and you see their components are multiples of each other or fractions of each other. Please go backwards. So when you're adding vectors, alright, you use triangular law of addition. Triangular. Alright, so alright, this is another parallel vector that I'm testing you. So this is 2b, vector 2b, which has these components there, and I'm asking what are these components of 1b? Just this is just half of that, isn't it? Because that's 2b. So just half those values, you get 5 and 1. 5i and 1j. Okay, so now here's the question. Vector A to B has these components. You might see components written in like I and J form. Then this is not column vector. So we want to find the resultant vector A to C. That means adding A to B and B to C together. So just component wise, you add them together. 5 and 4 makes 9, and minus 2 plus 2 makes 0. So that's why it is 0j. I didn't write 0j because it just means it is 0j, right? So C to A, if you have to go backwards from C to A, it's you would put a minus sign in front of each of those components. Everything will be getting a negative sign, therefore it would just be minus 9i, because the 2j and minus 2j will cancel away. Now, this final example, we've got a parallelogram, OACB. Notice we're reading it in like clockwise pattern here, AOCB. Then it says point P and Q, M and M are midpoints of those lines. So this is halfway between OB, this is halfway between OA, and so on and so forth, midpoints. So then the question is asking us, he's told us that O to A counted as vector A, alright? So O to capital A is vector A and O to B is vector B. So I put arrows there so you read it as a vector and express the following in terms of A and B. So O to C, how can I get from point O to point C? Well, I can use vector A and then pick up vector B, put it there, and it will take me there. So that's just A plus B. So going from point A to B means that now let's wipe those off. And A to B means that I have to travel backwards on vector A and go forwards on vector B. So minus A plus B or B minus A, either way it works fine. You can go forwards on B first and then back down on A. Alright, so then for part C, we are asked to calculate Q to C. Point Q is halfway here. Let's wipe those off. Q to C. So it's just half of, it's pointing in the direction of B, so we don't have to change the direction of B. We just have to take half of B. Alright, so we put a half in front of vector B. Then C to N. So point C is up here in the top top right corner. C to N. I need to go back in direction of A. So, and I'm only going to use half of A. So it's negative half A, isn't it? Q to N means that I need to go forward half of B and then come down at half of A. So just putting half B minus half A together. You can factorize this out. Now, I think there is a third part to this question. Yeah, it's saying it is asking us what can you deduce about vector A to B and Q to N. So if we look at the definition of A to B here, this is A to B and this is Q to N. What is it? What can we say about it? Like, do you notice anything strange or anything similar to each other? Right? You should have noticed this, right? They are, if I factor out a half from this Q2, and I did say that if you can factor it out, what you're going to get is B minus A inside the bracket, right? And what you notice is that this is just half of that vector there. So what did we say at the beginning about vectors being multiple or fraction of each other? What does that mean? I'm not showing you the vectors because that would make it too obvious. But uh, this vector q to n is half of a to b. Means they are parallel to each other. Yes, they don't have the same length to each other, but they are parallel to each other. So if you picture it, a to b is pointing here, all right? A to B is this vector here, and Q to N is this vector here. They are parallel to each other because after all, this was a parallelogram. Alright? So, and you don't have to draw the drawing to figure it out. You can just figure out here the point that I've underlined this definition of B minus A and B minus A are the same is telling us they are multiple fraction of each other. And it says in this box here, Qn is multiple of AB, so they are parallel. So actually there seems to be another question here. So in triangle OAB, M is a midpoint of OA and N divides AB in a ratio of 1 to 2 as such and such. So we have OM to be little a, so M to A is another A. OB is one vector V. Express ON in terms of A and B. So we want to go from this point O to N. Alright, and we said the ratio of 1 to 2 means that this is like 1/3 of entire length, and this is 2/3 of 1/3 of A to B, and so on. So you can read it from the graph or shape here. 2A plus, oh well, no, we don't know what A to B is. Alright, so O to N involved was calculating what A to B is. A to B, first of all, to write the definition of A to B, you go down minus 2A and forward on B. So OA is 2A, and we're just putting some numbers on the shape. So ON involves us going, rewrite the path for yourself. Alright, so you define what path you're going to take. I'm going to take O to A and then A to N. Now, A to N, we just said it's one third of A to B, and we don't know what A to B is, but I just told you it's minus 2A plus B. We're gonna put one third in front of what I just said. When we solve problems like so, you write everything explicitly for yourself. Don't try to hold too many things up in your head. So to go from A to B, you can write it explicitly. I'm gonna go in a reverse direction of O to A. So that's A to O. So that's minus 2A plus little b. Now I'm gonna put this back in the top, this line here. Put it one third in front of it. Write A to N as one third times negative 2 is negative 2/3, and uh, one third times b is just one third of b. All right, so it might have been better to have written an is one third of a to b, right? So that just rewriting that again is, I've written it there, but I'm substituting into that vector there. So I just put a bracket around this, and I putting that there. Maybe I should have put the numbers in. All right, then now I have defined what A to B is. I need to go and put these two vectors together. After all, I was looking for ON, wasn't I? So I just need to add these two vectors together, and 2A plus negative 2/3. You just have to be good at adding numbers with fractions here. Or taking away 2/3 from 2 means 1 and 1/3 is going to remain. What's 1 and 1/3 is going to be 4/3. Okay, so 4/3 of A remains, and uh, 1/3 of B is just added there. Okay, so here, look, we are, when you're adding and subtracting, you're adding just you can factor A out of this. If you don't know what's going on, you factor A out of this, you're just adding two numbers. You're saying 2 minus 2/3. Alright? If you can divide this into 6 over 3, we now good at this. So 6 minus 2 is 4. The answer is 4/3, okay? So 6/3 is just another way of writing it. Alright, so good luck practicing the first exercise, and I'll see you in the next video.